We can use the Linux command chmod or change mode to change permissions of the file or folder here. This is the command here we will use in this lecture. Only a root user or the file's owner can change permissions. In this lecture, we use chmod to change permission on hashcat.hc stat using two different methods. First, we use a numerical representation of permissions, and then we use a symbolic representation. Changing permissions with decimal notation. We can use a shortcut to refer to permission by using a single number to represent one RWX set of permissions. So like everything underlying the operating system, the permissions are represented in binary. So on and off switches are represented by 1 and 0 respectively. You can think of the RWX permissions as 3 on-off switches. So when all permissions are granted, this equates in 1, 1, 1 in binary. A binary set like this is then easily represented as one digit by converting it into octal, an 8-digit number system that starts with 0 and ends with 7. So an octal digit represents a set of 3 binary digits, meaning we can represent an entire RWX set with just a one digit. This can be 0, 1, 2, 3, 4, 5, 6, 7, 8. 7 actually. Lastly is 7, not 8. So here I will create a table here for better understanding here. So in binary, here this is the binary here, octal, and I will show you here is the RWX. So the binary is 0. If binary is 0, 0, 0, octal is 0 as well, and RWX not read, nor write, nor execute here. So if binary is 0, 0, 1 here, octal is gonna be 1, and this can be not read, not write, but executable here. If binary is 0, 1, 0, and octal is 2, then this means this is the not readable but writable and not executable here. And if binary is 0, 1, 1 and octal is 3, then this means this is not readable but writable here and executable. If binary is 1, 0, 0, this means in octal 4, so this means this is not this is actually readable, not writable, nor executable. And if binary is 1, 0, 1, this means in octal is 5 here, and this is readable. This is readable, not writable, and executable here. And so readable, not writable, and executable. And here we have 6 and 7. Lastly, 1, 1, 0 is equals to 6 in octal by a system here, and this is the readable, writable, but not executable here. But if all binary is 1, 3, 1, 1, 1, 1, and this means in octal we have 7 here, and this is readable, writable, and executable as well. So using this information, let's go through some examples. First, if we want to set only the read permission, we could consult the table and locate the value for read. For example, this is the read permission, and this is the 4. We can declare this using 4 or just a read write execute, or we can declare it in binary. Next, if we want to set permission to write and execute, We could use the same methodology and look for what set and what sets the W and what sets the X, which is executable and writable. So as you can see here, we have our WX here. So we want just writable and executable, and as you can see here, there's in octal, this is the 3. So in binary 0, 1, 1. So now we can pass an argument here where shortcuts come in. So for example, let's create a new file or dir here. Oops, my keyboard is actually okay. For example, touch here, example, oops, file. ls here. As you can see here, we created example file. This is not this has not inside anything. There's just a file with 0 bytes here. So let's declare ls la. As you can see here, we have example file here, which is created by Kali. So let's change this permission to chmod 774 hash actually example file. So ls la, and as you can see here, we changed these permissions here. So you should see rw here, rwx, rwx r here on the left side of this example file. So this confirms that this chmod call successfully changed permission on the file to give both the owner and the group ability to execute the file. So Linux use of permission to protect the users or groups, files, and directories from other users in the system can be used for offensive and defensive purposes. You should now know how to manage these permissions and how to exploit weak points in the security system, in particular SUD and SGID.